Hi, welcome to today's lesson on solving one-step equations. Okay, we're going to learn how to solve equations. And over the course of many lessons, we're going to solve more and more complicated equations until we finally are solving 5-step equations maybe. When you get to high school, you'll be solving 6, 7, and 8-step equations when you get on beyond and beyond. Okay, and that's just your first year in high school. I'm talking about, for us, probably going to stop right around 5. But to be thorough, I always want to start at 1. Let's start at one-step equations and work our way up. Now, some of you are going to be looking at this and thinking, oh man, this is so easy. Why is he even wasting my time with it? Or, I can do these in my head. There's no reason I need to really work at this. It's so obvious. These answers are so easy. But this is when you need to pay the most attention, okay? Is when it's easy. This is that weird thing, right? When it's the easiest, that's when you're most likely to make mistakes, and that's when you're not paying attention. You're not learning it. You get to that later stuff when it's not as easy, and you're thinking, what did I miss? Okay, I want to stop that from being one of you. Okay, I don't want you to be asking yourself, what did I miss? I must have missed something because this is suddenly not easy anymore. It was easy last week. It was easy 2 weeks ago. Why isn't it easy all of a sudden? And it's because you weren't paying as much attention as you really should have. So I want everyone to be giving me your undivided attention for this. Okay, obviously you're watching the video, so you must be giving me your undivided attention. But here's the key, okay? Step by step. I'm going to show you step by step. We're going to get to those 5-step equations, but we're going to go one step at a time. And every time we're not going to, it's not going to be that much more difficult. It's just going to be one more step. Think of it like learning how to walk. You know, you learn how to take that first step. That's pretty daunting when you're a little kid, right? And then a week later, you're running around the house like a crazy person, okay? Well, let's got to learn how to walk before we can run. So, solving one-step equations. And in order to solve an equation, what we're really trying to do is we're throwing out a variable, okay? We have a situation, okay? A something could be adding, subtracting, multiplying, or dividing, and then it equals something, okay? And we may use this, I promise you will use this more in your everyday life than you even realize, because you'll start doing it in your head. You won't even think about it as a variable. You won't even think about writing equations. You'll just be doing it in your head, but what you're doing is solving a one-step equation. So let's look at solving the equations, and for my purposes, what I'm really going to be also focused on is showing the work. Make sure it is clear how you got your answer. Because I have said this before, I will say it again, okay? Math is not about the answers. It's about the process to get the answers, okay? Because if you only get the answer, maybe you got it because you were right, maybe you got it because you were lucky, maybe because you asked a computer, maybe you asked your friend, maybe you asked a calculator, I don't know. But the problem is, if you don't know how you got there, you never know if you made a mistake, okay? So the process is what matters. I like to make a lot of sports analogies in all my classes. This is a lot like, again, shooting a basketball. I want you right next to the basket shooting the basketball, but I'm going to watch your form. I'm going to look at how your knees, are they bent? Are you following through? Is your chin up? Are you looking at the basket? Is everything right? If it goes in, great. If it doesn't go in, it's okay, we'll fix it. But if you get the ball to go in, but you only can do it when you close your eye, you put your hand over your eyes, you throw it over your left shoulder, and it happens to go in, can you do that again? Can you duplicate that in a game? What if we move you a foot? Is that going to mess up that ability to make that shot? Probably. Okay, so here we go. So, addition. X plus 3 equals 7. I know in your mind you've already solved this. Many of you gone, I know the answer. I don't care. I don't care what the answer is. I know this sounds crazy to say, especially as a math teacher. What do you mean I don't care what the answer is? I don't. I care about the process you use to solve. Okay, how do you solve this problem? Well, what you do is you do the opposite of what you see. Okay, somebody took your variable, added 3 to it, and got an answer of 7. And I say, well, what was the starting number? And again, I know you know it. They're shouting it out at me. But how would you get it if you didn't know it? If you just didn't know it, you said, well, you know what? How would you get it? Well, you told me you took my number and you added 3. Well, I will subtract that 3 back out, and now, yep, it's the answer that everyone's been yelling at me for. Okay, but what I'm going to be looking for is that operation, that step. Okay, because in order for me to get to 2-step, now I need to be able to see that you know what the 1-step looks like. Not that you just magically had answers, not that you did them all. And please, I know it's so tempting to tell me you did it in your head. Okay, those of you that want to tell me your parents, your friends, oh yeah, no problem, I just did it in my head. Hard to grade that, hard to see that, hard to know if you're right. Okay, this is like, maybe you just got lucky, maybe something went wrong, maybe you did the wrong thing but you got the right answer for the wrong reason. I don't know. Show your work. Subtraction, the beauty is it works the same way. It's just the opposite. So if I had x minus 3 equals 7, okay, you know, you're already, and I know you're yelling it out, what minus 3 equals 7, you know that answer, but I'm not interested in the answer. I'm interested in the process. So if I see subtraction, I'm going to be adding. And that's going to get me the right answer. What if I have multiplication? So 2x equals 10. So this is 2 times. Sometimes you need, maybe if you need that little dot to remind you this is a multiplication problem. And again, what's the opposite of multiplication? Well, that'd be division. So we're going to divide by whatever number is next to the variable. In fact, that last statement that I just made, dividing by the number next to the variable, is something you're going to do in your math class, in this class, and the one you take in high school in the 9th grade, in the 10th grade, and beyond. Probably, and I'm not exaggerating this at all, 1,000 times in the next year. So mark today's calendar, mark today's date, okay? A year from now, you will have divided by the number next to the variable 1,000 times. It's that important. And then, again, we're just solving x equals 5. Again, I know you knew what the answer was, but I'm telling you, I'm going to want to see how you get it, more than I'm going to want to see that you got it. Okay? I want to see the steps. And the last one would be division. Students struggle with this one the most, because this is something called a divisor bar. It means it's a division problem. We could also write it like this, but we really, most of the time, wouldn't. We'd write it as a fraction, and the opposite would be to multiply. Those are the 4 operations. Now, we could talk about square roots, but and using exponents. We're not going to do that right now. That is a lesson that will come later on in this year, but we are going to be doing it at some point. These are the 4 main operations. Okay? Add, subtract, multiply, divide. And we need to be able to undo them. Okay? And it's very soon, very next week, we're going to start putting these together. And that's why it really becomes important that you understand what the steps look like. And then if I say, okay, now I want you to do 2 steps, you go, great, I already know how to do each of them individually. Now only thing I have to know differently is which one do I have to do first. And we'll talk about that next week. But for right now, these are the 1 steps. Okay? You need to show the step. Okay? Let me make that clear to every one of you. All my students, all the people that have ever been in my class, ever will be. The work is so much more important than the answer. Answers are great. Don't get me wrong. When you finally take tests, yeah, answers matter. But you know what? You will find there are a lot of tests where getting the answer is worth as many points, if not more, than the answer itself. And that's what I'm going to be looking for. So when you see addition, you're subtracting. When you see subtraction, you're adding. When you see multiplication, you're dividing. And when you see division, you're multiplying. Okay? That's how you solve a 1-step equation. You do the opposite. Now you have to be a little careful. There are some times when it looks a little weird. So let me show you a couple of special times, and then we'll be done. Because I do agree, 1-step equations I think are pretty straightforward. As long as you understand, I just see something, I do the opposite. But what if I gave you something like this? I gave you with the variable second. What do I do here? Well, this is still addition, so I'm still subtracting. But I'm subtracting this number, which is a -2. Now what happens when I subtract a negative? I add the opposite. So you have to be careful, especially when they're out of order. Students always see it going forward, it's no problem. If it's x minus 2, everybody would get it. If I had written this problem like this, I think everybody gets it right and they know exactly what to do. But it wasn't as clear here because the -2 was first. But you just have to know. You've got to know what to do and what does it mean when you subtract a negative and so on and so forth. Honestly, that's probably the only situation we're going to deal with in the one-step equations that's going to be a little tricky, and that is just what do you do when they switch the order on you. Okay, so again, this is I think a pretty straightforward, pretty simplistic lesson. But again, I guess I shouldn't put my pen away because I really want to say this in great big letters. I want to make this super, super clear, especially if you expect to get credit on your homework. Show your work. Just getting an answer is not enough. How you got your answer is far more important to me than what the answer is. I mean, I know that sounds crazy and it seems counterintuitive, but I really want to know how you got your answer, because as we go on and on and on, and I start adding steps and adding difficulty, I need to know that you know that all I'm asking you to do is basically take 2 steps instead of 1. Okay, because I have students every year that do this. They're like, oh, this is so easy, I don't need to show my work, I can do this in my head. This is so easy, I don't need to show my work, I can do it in my head. This is so easy, I don't need to show my work, I can do it in my head. I can't do it. And that should not happen, because if you can show your work every time, it's like, hey, look, I took a step. Hey, look, I took 2 steps. Hey, look, I took 3 steps. Until finally, you're taking 5, and then you hit the high school and you're taking 6, and you're taking 7, and you're taking 8-step equations, and all you're doing is a little bit longer. And I assure you, I promise you, you will use this skill years down the line. So master the skill now. Don't fight against it because you think it's too easy. Just say, fine, this is what he wants. I can do that, it's no problem, it's easy. Okay? Because then I know when you get to the more difficult stuff, you will not find it so difficult. You'll find it just as easy as this. Okay? I'll see you in office hours or in class. Bye.